All right, guys, this is your video lesson for eclipses. So we've talked about moon phases, and now we're going to touch on eclipses. I know a lot of you have asked about this while we were learning about moon phases, so we are going to talk about eclipses today. So this is your bell ringer that you see on the screen, so do me a favor, go ahead and pause the video, write down these questions, and try and answer them as best you can, and then we'll compare notes with what they actually are. All right, now that you have answered your bell ringer, we are going to go through the notes together. So we are talking about eclipses today. All right. So our first two questions of the bell ringer were what is a solar eclipse and what is a lunar eclipse? So this is what they are right here in front of us. All right, so a solar eclipse occurs when the moon casts a shadow on the earth. Okay, so the sun is what is blocked from getting to earth. So it is a solar eclipse. Solar means sun. So a solar eclipse is when the sun is eclipsed. The sun is blocked from getting to earth. That light from the sun is blocked from getting to earth. This occurs during a new moon phase. So if it's a quarter moon or anything like that and the sun goes dark, we know that there is an issue that is not a solar eclipse. Okay? And the sun does appear to go dark when there is a solar eclipse. So I know some of you got to see the solar eclipse a few years ago, but for us here in Lancaster County, we only saw a partial eclipse. Okay, and we'll talk about what that means in just a second. All right, a lunar eclipse is when the earth casts a shadow on the moon. So since the moon gets its light from the sun, when earth casts a shadow on the moon, we don't see the light from the moon anymore. It actually changes, it turns red in this case. All right, so lunar means moon, so the moon's light is what is being blocked from getting to earth. The moon's light is what's being eclipsed, and eclipsed means it's being blocked. So a lunar eclipse is when the moon's light is blocked. All right, and this occurs during a full moon. So we get a really cool picture when we get to see a lunar eclipse because the moon is big, it's bright, we can see all of it as long as it's not cloudy, and then it turns red as it passes through the Earth's shadow. All right, we are going to talk about these two shadows really quickly because there's not just one shadow that's cast during an eclipse. We have two shadows. We have the penumbra, which is a lighter and larger shadow that's cast during an eclipse. And areas in the penumbra experience a partial eclipse. So when we had that eclipse in, I believe it was 2016. When we had that eclipse in 2016, we were in the penumbra here in Lancaster County. So we didn't get to see a total eclipse here. I actually drove all the way to Columbia to be in the umbra so that I could see the total eclipse because I thought it was really, really cool. And I've got some neat pictures to show you later on. Okay, so the umbra is a darker, smaller shadow cast during an eclipse, and people in the penumbra experience a total eclipse. They're able to see the sun go completely dark. All right. So now let's talk about our diagrams just a little bit, okay? So when we see a solar eclipse, when we look up into the sky, this is what we see, that right there, that picture, well, these two pictures up at the top, and down here across the bottom, this is what we would see before the eclipse becomes total. And if you were wearing those special glasses that allowed you to look at the sun, this is what you would have been able to see. This is the sun on a normal day, what it looks like without the eclipse. Right here, you can see that the moon is just starting to cover the sun. And as you continue to move on, it gets more and more covered until it is almost completely covered. And then once it is completely covered, it looks like this right here. And that is the corona that we can see around the edge of the moon. We can see the sun's atmosphere, okay? And this right here is a diagram of what that would look like. So we've got the sun, we've got the moon in its position that we're going to have a new moon, and then is casting a shadow on Earth. And that penumbra is that larger shadow right here, and it's a little bit lighter. And the umbra is this tiny little shadow right here, and it's going to be darker, and you're going to experience a total eclipse if you're inside that small shadow here on Earth. Okay? All right, this is our diagram for a lunar eclipse. This is what it would look like if there was a lunar eclipse and it was a complete eclipse. You'd be able to look up at the night sky and you'd see this right here. As we are moving into the eclipse, we would see something that looks kind of like this down here across the bottom, okay? So we start out with a regular full moon. It starts to go kind of dark. It looks funny, and then it changes color, and then it's finally completely inside of Earth's shadow, and it does turn red. And the reason it turns red is because Earth's atmosphere bends that light just a little bit and makes it turn red. So it's almost like having all the sunsets and sunrises projected onto the moon. So that's why it turns a reddish orange color. And this is similar to what we would see when we have harvest moons. That would be close to a partial lunar eclipse. So it is changing colors because that light is passing through Earth's atmosphere and it's shining on the moon in a way that makes it look orange. All right. So just in words, because I know that helps some of y'all, we're going to talk about why we see eclipses, but why we don't see them every new moon and full moon phase. All right. We do not experience eclipses every new and full moon phase because the moon's orbit is tilted about 5 degrees and it wobbles as the moon orbits. This tilt and wobble means that the sun, moon, and Earth do not always form a straight line each month as the moon orbits Earth. This makes eclipses rare. Solar eclipses are more rare than lunar eclipses, though. Right? So instead of the sun, moon, and Earth being on a completely flat circle and orbiting all on the same plane, the moon's orbit does tilt. So it wobbles as it orbits around Earth. So it's not completely flat. So it's kind of like if you've ever dropped a quarter and watched it spin and it kind of rolls a little bit, tilts around until it lays flat. That's what the moon's orbit does. It tilts and rolls around as it orbits around Earth. So we don't always have eclipses every full moon and new moon phase because the moon's orbit is tilted and it wobbles. So it's not just tilted and it stays in one position. It wobbles as it orbits around Earth. And that's what allows us to see eclipses at all, because if it didn't wobble, if it didn't move into that straight line with the sun, moon, and Earth, if it didn't make a straight line with us, then we would not be able to see eclipses at all. All right, so this video right here explains eclipses a little bit better than I can. They're showing you some big 3D models, and they're explaining why it's important that we see eclipses, why we need to understand why we can see them, and things like that. All right. So once you've watched that video, that is the end of your lesson today. Hopefully those diagrams and all that stuff they can show you in the video help a little bit, as well as this video lesson with the diagrams over here.